Hey everybody, before we get started here, I just wanted to let you know that in this episode we had some less than ideal recording circumstances. So there's a little bit of background noise. We also had issues with our internet connection, which somehow murdered our primary copy, our high resolution copy of the podcast. So we had to use our lower quality backup for this episode. I apologize for that. It is what it is. I can't go back and fix it. And I hope you still enjoy the episode. Hey everybody, welcome back to the 92nd episode of Taps and Patience. I am AJ with Audacity Micro here with Harrison from Precision Ingenuity, and we have Prescott from Onesie Twosie Systems. Hi guys, how you doing?
Exhausted.
Exhausted? Same.
I'm doing well.
That's good. I'm glad someone's at least getting some sleep here.
I should say I'm not more exhausted than usual. I have small children, so still a little exhausted.
Yeah.
Yeah. How small?
I've got a 5-year-old, a 3-year-old, and a 4-month-old.
Okay, so you're like 2 years behind me, basically, because I have 7, 5, and 3 right now.
And I have none.
You have none. He has a cat scratching at the door.
Yeah, I have a cat scratching at the door. So, but anyways, what's going on? What have you been up to, AJ?
Let me show you. I made sure I could do the screen casting just so I could show you this. Oh, wait, where's the button? There's the button. There you go.
Oh.
Can you see that?
Gorgeous.
Ooh.
I have been working on this thing for like a week. This is before finishing even.
Ooh.
It doesn't work.
Awesome.
It doesn't work.
It doesn't work?
It doesn't work.
It doesn't rotate?
Nope.
Why?
So I have two theories. Let me go back to face cam so I can show you everything else and see you guys. I have two theories. One is a design issue. The other one was a manufacturing issue. Manufacturing issue, start with that one. I think my gears were slightly oversized, which I think by about 2 thou based on my measurements. I didn't figure out how to measure them until after I realized there was problems. So all of my gears are about 2 thou oversized, which there's 3 different gears in the system if you include the ring gear. So that's a total of 6 thou oversized, which is a lot. And so as a result, that center bridge, which I call the linkage, is then too big and it was like causing the gears to kind of get tilted sideways. And they kind of like, I tried, out of plane. And I was hoping that I could just like wear it in. So like I put some lapping compound in the joints and just like turned them, hoping that it would just like wear in. And it didn't. They just were scraping against the bottom of the linkage.
Is that bar only on one side?
And okay, let me go back into screencast mode. So that was the. Oh yes, I'm sorry. It's only supported on one side. How do I do it? There we go. Yeah, so the bar's only on one side. It's not supposed to have any load, so like it doesn't really matter. This, by the way, is a espresso tool. It's missing some distribution needles on the backside of the large gear in this picture.
Okay.
So this linkage was too long. I initially designed the thing to be pretty tight tolerance, so it would turn nice and smoothly without like a lot of play. But then when the gears were oversized, it just kind of jammed up. But then I did eventually just kind of get that sort of fixed by like wallowing out those holes with a reamer. And I don't think this design would have ever worked. I think having just the 2 points of contact on that outer ring gear was overly optimistic. And it's always going to try to jam itself up or down instead of rotating.
So it's only got the 2 gears, and then that little outcropping is just a handle?
Correct.
Okay.
And so I spent today redesigning it, and I have 2 of the gears. I had to make another gear, but this is now going to be the new linkage.
Gotcha.
It's looking pretty good. It still needs to be, again, it needs to be tumbled and anodized, but This will hopefully solve all of our problems. I gave it a lot more clearance. It seems to fit better in there, and the knob to spin it is now much larger and easier to get a grip on. Plus, the knob is now in the center of rotation instead of being offset, which I think will kind of eliminate some of the weird forces on it.
What are you using for a bearing surface? Is it just riding in, like, is there any kind of bearing surface, or is it just riding on the bridge?
It's kind of like a shoulder bolt, if that makes sense, where there is a precision surface sticking up off the gear, and then there's a screw going down, and the screw, or theoretically the portion of the gear sticking up, is long enough that the screw can tighten down on that without pinching that center linkage.
Gotcha.
So I think in reality, the piece of titanium, the center, this is all titanium, if I didn't mention that. I think my center piece here that I'm calling the linkage, I think I made a little bit too thick, and the screws are rubbing a little bit, but I'm just going to, unscrew in 1/8 of a turn and put some red Loctite on there, and it'll be fine.
Do they free spin on their own then, outside the assembly, pretty easily?
Yes, now it does.
Okay.
I don't know if you can see that. Yeah. So now they spin.
Okay.
But man, this part has been kicking my butt. Or this whole thing, because I'm at about a week now from I have an idea to finished thing. And so I had to do, all the design work, and I did a couple prototypes, which my plastic printed ones worked fine, by the way. But I think it's because I made them overly sloppy to account for the 3D printing. So I don't know. That's been my week. There's also a video that's going along with this. It's going to go up on Next Gen's YouTube channel. But this is an IMTS demo part, and IMTS is getting awfully close here.
Oh man. Best of luck.
So that's what I've been working on. I think I have the second gear on my machine now. I just need to flip it for Op 2, and we're done here. And I think that does it. I think that'll be the last thing, and it'll be done. And then I just need to edit the video.
Good deal. And that's what's been eating up all your time, more or less?
That's been eating up all of my time.
Gotcha. For how long? How many days?
It's been about a week now.
Oh, man. I've had the opposite problem. I've been producing over 100 parts a day.
With 3 machines? Because I think it's been a while since we've talked on a podcast.
Yeah, so I finally got a third machine going, and we can talk about that because it is an adventure, and it is expensive, and it took a lot longer than planned. So technically, it only got started running this week.
Okay.
For like Friday last week, at the end of the day, for like an hour, maybe half hour to an hour before we closed down. So yeah, it's been between last week and this week, it's been a lot. I don't think I've made it home since before 10 o'clock, except for today and yesterday, because I've also started teaching again part-time at the local university. And so apart from those 2 days, I think I've been at the shop every night till probably about 10 o'clock or later.
To be clear, you never stopped teaching for him. It was just summer, right?
Correct. I never stopped, but this is probably going to be my last semester. So I've already kind of warned them that, hey, business is picking up, things are rocket shipping up, and it's going to be a struggle for me to do this semester, let alone any future semesters for the foreseeable future, and until things get under control. But we can go in that a little bit more a little later. I want to hear a little bit more from our guest, who's been quietly sitting.
Sorry, we've been like ignoring you for the last 9 minutes.
So, go ahead. I was just going to say, why don't you introduce yourself and tell us a little bit about you? I know we kind of got into it a little bit, but I want to hear a little bit more information about your kind of background and what's going on in your world.
Yes. So my name is Prescott. The company I'm representing today is just me, and it's Onesie Twosie Systems. Um, I uh, currently have a day job. I work as a toolroom machinist at a company that does precision optics. So several years ago, I moved to Rochester, New York, which is actually, I didn't know this, but it's a center of the optics industry in this country. So after doing some odd jobs, I went to school at Monroe Community College for optical systems technology, which is a pretty unique community college program. Uh, so at the University of Rochester, there's one of the big optics university programs in the world, and that turns out a lot of people that know a lot about how light works. Um, several Nobel Prizes have come out of work done there on lasers and things like that. And then in the surrounding area, there's the remnants of Kodak and Bausch and Lomb and Xerox. Uh, you know, a lot of the important businesses have been spun off into other things. But the equipment is here. The people are still here in the city. And so you can learn on the job how to make optics out of glass. But that's mostly about glass. It's not about light. And the program that I was in tries to bridge that gap a little bit, and I think it's pretty successful. So while I was studying that, I got a job at a machine tool builder called OptiPro that builds machine tools for grinding and polishing optics. Very niche, very small machine tool builder, but I certainly learned a lot of things. And then I got to working on. Oh, go ahead.
I was just going to ask, when it comes to grinding, are those also on CNC machines, or is that manual or by hand?
The machines that OptiPro makes are CNC. And when it comes to grinding, machinists talk about grinding, which is like a fixed abrasive process with a stone or maybe a super abrasive in a metal or resin bond. And then there's lapping, which is loose abrasive processes. And maybe you might have something like buffing, which is a loose abrasive process, and the tool is so floppy that we're really only concerned about making stuff shiny. Opticians would say that, like, opticians, people who make precision optics, don't distinguish as much between fixed abrasive grinding and loose abrasive grinding. They call it grinding when there's a hard tool, when the tool is cast iron or glass or something like that. And then they would call it polishing when the tool is like a thermoplastic or pitch, which is the main one, or felt, something like that. And polishing, when it comes to glass, also has this chemical component. It's a chemical mechanical process. So it produces a very fine, like it produces a different surface by a different mechanism. You can't just grind with successively smaller abrasives and get a good optical surface in glass. You have to switch over from diamond or alumina abrasive to ceria, which is also doing this chemical job at the same time.
There's probably a lot of just industry knowledge that is just very condensed in that area for that kind of stuff. This is like a topic that I'm sure we could go like a mile deep in.
Oh yes. And it's really fascinating because I'd been doing machining on sort of a hobby basis for a few years here and there, and there's a lot of good material online about how to do machining and how it works and stuff like that. There was almost none of that for making optics. The only thing you can really find is from amateur telescope makers. And they publish a lot of their stuff. It's a really rich source of information, even for the professional. But when it got to be time to look around at what sort of job to do next, like because of the place that I found myself in, it was like a kind of a once in a lifetime opportunity to learn something that can't be learned any other way. There's so much in optics that you have to learn either by trial and error or by finding the Kodak retiree who did learn it by trial and error and asking him about it, listening to some of his disturbing stories, and then also you get the nuggets of knowledge.
Is there a risk of some of this information just disappearing forever? Like, is this like there's a lot of stuff that we can do, like you said, for machining. It's a constantly evolving field, but in the field of optics, is there any kind of fear of like these people are retiring and this knowledge is going to be lost to the sands of time?
There certainly is, and it's not that it can't be rediscovered, but there's like that takes time, and it takes time to train people. So like one of the things we do at my day job is, they'll have a really difficult part. We had this part that was a hyperhemispherical dome. So imagine a fishbowl, right? So it was most of a sphere, 3 millimeters thick, maybe 6 inches, 150 millimeters in diameter. But it was a thin shell all around. Like that's a really hard part to make out of fused silica. And the customer had a supplier in Germany, but he was using the sort of old school artisanal methods, and like they couldn't do any more than two a month for any price. It was just like, it takes 20 years to train this guy. Like, too bad. And so we tried to figure out ways to do it that were a little bit more mechanized, a little bit more computerized, so that like if you drop $1 million PO, yes, we can buy the machines, and yes, we can do 10 a month. And the U.S. Navy has started to look at this problem and how it impacts them. So they've spent a lot of money at Monroe Community College trying to duplicate this program elsewhere in the country to get more people who know how to do this optics stuff, this brittle materials, precision stuff.
So kind of taking a step back, like what, okay, so someone comes to you and says, hey, I need a, super high precision fishbowl. Like, how are you getting that shape? Like, are you starting with a block and subtracting your way down? Are you casting it? Like,
almost always. So like, the fishbowl shape is something that like can be blown in glass or like molded in glass fairly easily, but that the shape isn't really going to be very precise. And even if you were to machine that shape, if you were to do a near net shape type of thing, there's stresses in the material, there's inhomogeneity in the material that will dramatically impact its optical performance. So like optical glasses are cast or extruded in like thick slabs, like really long, thick slabs, and they grind and polish the two sides, and they can put that in an interferometer that can detect the inhomogeneities and can detect if you with a polarization interferometer, it can also detect really minute amounts of stresses. So like the highest precision optics have to be made from block like that. There is molding that you can do for some types of optics if you can allow a little bit of inhomogeneity, but if you really need to know exactly what the optical properties of that material are, it has to be made from that block. And it's not uncommon to do a melt fit, which is where they, an optical designer will make a rough design for a system. They'll buy the material and measure it, and then adjust each of the curves, each of the surfaces ever so slightly to deal with the optical materials of that particular batch.
How does one even machine a glass? Like, it's not going to be your traditional cutters. Is it because I've seen cutters.
It's all diamond grinding all the time.
All diamond grinding all the time. Okay.
Until you get to so diamond grinding is really the best way to do it. I know that there are PCD cutting edge tools. I'm not really familiar with those, but diamond grinding is really the way to do it. And then that leaves not just a rough surface, but subsurface damage, which is roughly proportional to the size of the abrasive particles. And then, so usually you have a rough diamond, which might be a 100 grit, and then a fine diamond, which may be a 1200 grit. And then you can go to loose abrasive optionally, and then to polish. And usually you still have to polish maybe 20 microns off the surface, or 0.8.
So speaking of like feeds and speeds of like grinding a block of glass into a fishbowl, what would it take to like what would be like a cycle time on a grinding process from like a rough from a block down to say like we would do in machining, like where we adapt away and then we come in with all of our finishing strategies? What would be the time frame to go from like block to ready for to having the rough shape done?
I mean, so for like a decent sized workpiece, like you could do the rough fixed grinding and the fine fixed grinding usually in like maybe an hour or two once you got it dialed. If you wanted to do more complex features, which is usually what we're doing in machining, right? The shaping, so that could be lightweighting, that could be putting mounting features, that could be making it into a pentagon so it fits into this bizarre system, whatever. Sometimes that takes longer. And then the polishing is often what takes a long time, depending on the material. Some polish faster, some polish slower, and also the how accurate of a sphere the surface needs to be. And then if it needs to be an A-sphere or a freeform, sometimes that can take weeks. Who knows?
How many machines are touching this thing throughout the process? Are you sticking it on one multi-purpose machine, or is it a bunch of very specific machines?
It is so if you include measuring machines, because measuring is not just something that happens at the end, it's something that happens all throughout. There's a feedback process. Like, I don't know of any machines that are practical for making like a whole optic by themselves. Unless it's plastics. Plastics is a different story because you can do molding, you can do diamond turning. There's different stuff for that. And even if you had one machine that could do it all, which is true for some of the simple machines, you have to clean the machine out, and that's much harder than moving it from a grinding machine to a polishing machine. But yeah, so maybe 4 or 5 machines is pretty typical.
And those machines are designated based, like you said, on the type of cutting they're doing, grinding, so you don't have to clean them out?
Yeah, as long as jobs? Yeah. In general, you don't have to clean them out between jobs. There are different polishing slurries that are usually most slurries that will work for glass will work for other glass, even if it's not ideal. If you want crystals or ceramics, then that's always going to be a diamond slurry. That's a whole different category. But glass, it's almost always Syria or similar.
So the first step, the roughing, is that done on something like a mill then?
Yes. So it's done. I think the closest analog would be a Blanchard grinder, and if it is if it's a plano optic, if it's a window or a prism, it's actually a Blanchard grinder. Okay. And glass isn't magnetic, so usually you're pinching the workpiece between some steels. And then the next phase would be like a curve generator.
Because it still is using a mag
chuck. Yes, it still has a mag chuck, yes.
Wow, okay.
You can also use a vacuum chuck. Vacuum is used to great effect, especially for large workpieces. When it gets smaller, you start to use glue and wax and pitch. There's not enough area for a vacuum to really do the job. It's almost never any kind of clamping. Certainly not with hard jaws. The clamping, the closest thing to clamping might be a press fit into a Delrin chuck. Maybe augmented by vacuum. So that's like one of the big differences between like machining glass and machining metal or plastics is the work holding. Not only is there the risk of shattering or scratching, but the surfaces that we need to make at the end of the day are very accurate, and distorting the workpiece through clamping is usually a non-starter.
So what kind of see if I can find a good way to word this. As you get to like if we're going back to your fishbowl, I can think of like trying to hollow it out. How would you drill in glass? Like it's still going to be a grinding, but is it like do you like grind a hole all the way down and like open it up, or do you just like slowly dish it out layer by layer and do the whole area and kind of like grow it into that fishbowl?
So for a convex curve or a concave curve that's like less than a hemisphere, what you would do is you would take a ring tool or like a dish sort of wheel, and you make sure that your workpiece is spinning on a turntable. The head of these machines, a lot of the machines look like a VMC, only there's a turntable or there's a platter on the table, and then the head tips. So the head tips, and based on the diameter of that cutter and the curve you're trying to make, it tips at a specific angle, so that as the workpiece is turning, you generate a very accurate sphere. You get an accurate sphere almost for free. Like if as long as it's not a super floppy workpiece, you get within 100 microns of spherical almost for free. as you know, you have to adjust for a nib in the center, or you have to maybe adjust the radius depending on the tool shape, but it comes out pretty spherical. And that works for convex and concave. It works for convex, even hyperhemispheres if you come in at an angle. But for concaves, once you get past a certain hyperhemisphere, you can't get the tool anymore that it's able to do that all in one go. So what we did is we kind of like drilled most of the way down, and then we had some ball tools made that would kind of scoop it out little by little. And the trick there is that, like, with a ball end mill, you have the dead spot in the middle, but usually it's not a huge deal. With grinding, it kind of is a big deal. You really are not getting any work done with that zero velocity spot in the center. So I had to learn a lot of the more fun tool axis control checkboxes in my CAM software in order to make that happen. And then there's almost always a
that was gonna be my next question.
Yeah,
is programming. How are you programming these things?
Yeah, so the OptiPro is like the American company that I know that makes CNC machines of this type. There's Schneider and Lowe and Optotech in Germany, but they all have software that kind of does most of this math for you for simple stuff, and a lot of it even for A-spheres, where you have a sort of arbitrary curve that you're trying to make that's still radially symmetric. And then usually what it is you do a test cut and then you measure and then you compensate based on what you measured. Like, that's the whole name of the game. There's no cutting once and then sending it. And even in a production context, it's like you're making one compensation every 2 parts or every 5 parts with the fine abrasives. Those wheels wear pretty quickly.
So how does that feedback loop work? How is the error information getting back to the machine to fix it on the next round?
Typically, there is a probe that you can use in the machine. And most of these machines don't have tool changers, by the way. You have to change the tools by hand. And usually there will only be like 1 or 2 or 3 for a particular part, so it's not a huge deal. But sometimes one of those things that you can put in is the probe. Or sometimes, if you have a head that tips, you can just mount the probe on the side of the head and then rotate it and probe your part.
Is that like a Renishaw probe, or do you guys have a different type of probe that you would use?
It's the thing I've seen is Marpos, but it's the same deal.
Okay.
And then often there would be another one on the table next to the platter for measuring the tool, because the tool geometry is most of the thing that you're compensating for.
Are they going to be touch probes, or are they going to be like force feedback probes?
I think they seem like pretty simple touch probes.
Huh.
Interesting.
I
would have figured for optics you'd want to put it on there and drag or something to profile it.
So the in machine, if it's you can do like multiple touches, or you can have a spherometer, which is like a depth gauge where there's that sort of flat thing and then the travel indicator. It's like that, only instead of the flat kind of narrow rectangle, there's a ring, and that can tell you your radius pretty accurately, especially if you're measuring against a reference sphere. Or for the fine stuff, what they do is they'll take the part out of the machine and send it over to the polishing department, and they'll polish it a little bit. They'll get a little bit of a shine on it. It certainly hasn't gotten through all of that subsurface damage, but you can still put it on the interferometer, or you can do a test plate, and you can see fringes, and you can get a really accurate idea of the radius.
So, kind of going back to my question a second ago, how is so the machine is gathering measurement data, and it is automatically compensating itself, or is it talking to the CAM software, or just like spitting out a report and then you have to manually do adjustments?
Like, it tells you a number and then you have to do the adjustment, because sometimes you undercompensate or overcompensate. And I'm sorry, hold on,
That's fine. I'll do Patreon announcements. We have a Patreon, including people such as Prescott, who has joined us today. And I swear I pulled up the spreadsheet and I have lost it now.
You did have it up at one point.
Do you know what I did? I closed it when I was going to do the screen share because I was afraid that I would dock someone. But we have a Patreon. Patreon perks include such experiences as occasionally joining us in a group episode, which I literally just published right when we launched this. Everybody gets access to our Patreon Discord, which is active now. Our Patreon Discord is active. There are conversations in there. Shout out to the people who have been keeping that thing alive. I have not done a great job of joining you. I'm sorry. I haven't been on Discord much lately because I've been making coffee ground distributors. But the Discord is now actually a perk. And now Patreons get your name on our website, which I will show you guys in a second here. But huge shout out to our Patreons. Specifically, we have Trey from Vestal Machining, Guy L, Eric H, Alex B, Scott from Design the Everything, Jamie from JSpec Engineering, Chris from Zyke Precision. Is that how he said it was said?
Oh man, don't ask me. I'm gonna get it wrong.
I'll have to re-listen to the Patreon episode because I've been saying his name wrong for years and he didn't tell me until now. I think it was Chris from Zyke Precision, EJ from Nocturnal Welding, Simon V, Chris at Thought Bomb Designs. We have Prescott at 1Z2Z Systems, and as ever, Jake Brownson. On that note, we now have a website as well, which I'm going to try to screen share with you guys here. Where's the button? I need to find the button. We are both an audio and a video podcast, so there we go. If you guys are listening on a podcast player, you can go find us on YouTube. If you're watching on YouTube, you can find us through a normal podcast feed. The website is starting to become useful. This is what it looks like right now. It is a Wikimedia page, so it's just like Wikipedia, but on our own hosting. It will be tapsandpatience.com by the time you listen to this episode. But on this website, we have a couple things. So first of all, there's this kind of welcome page. On the welcome page, there are some community tasks. So if you guys feel like contributing to the website and you have a couple minutes, you can go check out those community tasks and you can kind of help, everybody by spending a little bit of time on the website. Patreons. So Patrons, I have a Patreon tab right on the very first page. If you would like to add your social media or website to this front page here, you can do so. And then anybody who comes and checks out the website can find you guys. So obviously this will be public. So, put something that you want people to go to. I did not want to assume what websites you would want to send people to. I didn't want to, accidentally dox anybody. So all you have to do is hit edit and then you can add your own link. But more importantly, the whole purpose of this website is we now have episode pages for each episode, complete with summaries and complete transcripts. So if you ever need to find something that Harrison or I said in an episode, you can just come search this website and it'll point you to a transcript. We have almost all of the episodes transcribed and uploaded. There's a small handful of ones that have issues. I just upgraded our little Python script to handle guests today. So any of the episodes with guests don't have, well, this one has a transcript, but it's wrong. But they should still at least have the summaries. So, and then lastly, I have added a resources page where I have included some of the CAD models that I frequently get asked for, such as the soft jaws for that little Chinese vise I have, or my 3-jaw and 4-jaw chuck adapters for the Saunders Machine Works palette. So again, this is a Wikipedia, so you guys can edit this. Please don't abuse that. I will block you if you do something dumb, but I trust you guys. And together, if we all do a couple minutes of work, we can make this a really good, actually useful podcast website. No offense to other podcasts, but none of the other podcast websites are useful. So I would like to fix that on this. But our guest is back, so I will stop yapping as soon as I figure out how to turn off my screencasting. It's fine. I have kids. I understand. It's probably about bedtime too.
Oh yeah, because you're gonna You're gonna be ahead of us, in the time zone, at least way ahead of me.
He's
Yeah, I'm
same as me.
Eastern daylight here.
Okay, so we
Yes.
talked about where you worked for a while. So you were thinking about spinning up a
Well,
side
yeah,
business,
so
or started spinning
I
up
think
a side
maybe
business?
2 years ago,
Where you at
they
there?
asked me to move from the grinding and polishing side of things into the tool room, where I make the fixtures and the tools and the whatever that everyone else needs in the building to do their jobs. And it's a very small shop, so that's pretty expansive. When people start, I tell them, hey, if you can imagine a shape of a piece of metal or plastic that would make your job easier, that's the thing to bring to me. So I do spare parts for the machines. I do fixtures. I do who knows. Never know what's going to come through the door, which I love. But in the process, I've had to teach myself this trade. So yeah, a lot of the work is fixture work, and it's very special fixture work for glass, right? We can't clamp on it in the same way that we're used to clamping in the metalworking world, which is fun. It's a lot of vacuum. It's a lot of glue, wax, pitch, whatever the people come up with, which is sometimes odd stuff. It's something that they heard from some Kodak retiree 5 years ago that worked with this material, and who knows. So I've been making laps out of Teflon and zinc lately, is one of those things. But that's still the day job. I started to accidentally moonlight. A friend of mine was over and he was complaining about the parts that he was getting from Xometry. And I said, well, I don't know if I could do that cheaper, but I could do it better and I could do it faster. So I've been toying with the idea of job shopping for a little bit, but that gave me the motivation. And I started, I did the LLC thing. I am currently using the Tormach at the local makerspace with no tool changer and an incomplete enclosure. But I think that'll be enough to give me what I need to know, which is whether or not I like this whole job shopping thing.
Honestly, for job shop work, if you're doing low quantities, having to manually change tools is not the end of the world.
Yeah, and that's, when I was doing the optics CNC machine, when I was doing the optics CNC machines, like, those don't have tool changers. I'm used to that. And I can do well for maybe the first 10 or 20 parts. I got moved off of the grinding and polishing when I started to scrap a little bit too many, when we started to get into the serial numbers in the hundreds, because I just got bored. And glass is an extremely unforgiving material, as it turns out.
I bet.
Right, there's scratches, there's shattering. Lots of the glasses that are optically useful are...
You're fine, just keep going.
Here you go. Enjoy that lemon juice, kid. A lot of the glasses that are optically useful are highly thermally sensitive. Right, so steel might have a coefficient of thermal expansion of, I want to say 7 or 8 parts per million per degree C. Ordinary glass might be 9 or 10. Fused silica or borosilicate glass is great because that's only 3, and fused silica is like 0.5. And Zeradur or clear ceram is parts per billion. But then there's like fluorite glasses or calcium fluorite crystals, which have, can get up into the 20s. And they're brittle materials, so unlike an aluminum or a plastic, they just crack right down the middle. I've had parts that were scrapped because a drop of coolant fell from the ceiling of the machine. One drop fell from the ceiling of the machine onto the part while it was warm, and it was game over. Crack right through the center. So, glass is very unforgiving.
Man, I'm glad I don't have to deal with that.
Yeah.
I've done a lot of parts recently for optical companies. For some reason that I cannot explain, like a quarter of my business or more has been small, clear acrylic pieces over the last, probably a month. I've made hundreds and hundreds of small acrylic pieces that were all like under an 1/8 inch, both in thickness and in any other dimension. And even those are a pain. Like, I can't imagine having to deal with these issues on glass.
Oh yeah, and one of the advantages early in our business was being reluctant to no bid. A lot of our good early jobs were stuff that a prime defense contractor with bottomless pockets was shopping around for a year and couldn't find anybody to take.
So just like coming from the glass side and then like starting to work with like a Tormach and machine it. Like I can imagine being a machinist trying to machine glass, but like what's it coming from the other side of like machining glass and then coming to like another material and trying to form it? Is it like, oh man, this is so easy. Like it doesn't break if I look at it wrong.
Yeah, it's a lot less stress, and like the glass is so specific, like that we don't stock any of the optical materials. Unless it's maybe something really small out of fused silica. But so like if I drilled a hole in the wrong spot of a part that was in this fancy glass ceramic composite for a customer, like then my boss would have to get on the phone with the customer, and like even if it was something that wouldn't be an issue in the application, it still wouldn't conform to the drawing, so it'd be a big old deal and an embarrassment. Now that I work in the tool room, I work with metal, and I do stock material because I need to respond to things same day. So if I drill a hole in the wrong spot, either I throw the piece out and move on, or I'm also making the part that it mates with. So guess what? That's the new right spot. So it's way lower stress in that way. And one of the things, like, because occasionally, I'll go out and the opticians will have to drill a hole, or they'll have to machine some part of a fixture in situ in their machine. There's often benefits to that. There's so many fewer ways that it can go wrong. And like trying to convince them that like you can drill holes in aluminum really fast. And they're like, okay, yes. I heard that you said we could do it fast. I went to 4 millimeters per minute. In grinding, usually you cannot cut too slow and you can't make too light of cuts. And with a cutting edge type of machining, you absolutely can do that, especially with more hardening materials.
What kind of machines do you have at work?
So when I started out in the tool room, I only had manual machines.
For some reason here, the recording cut out, so you guys will never get to know what machines he's running at work.
And that's about it. Since then, I've gotten a surface grinder, which is a game changer, and a VMC that was probably made when I was 5 years old. And it once had a tool changer, but it no longer works. It's got no enclosure. It cut graphite for decades. It's kind of a piece of junk. They found it for $2,000, but that's still a game changer.
Hi again. We also briefly lost this segment of audio. Don't know why.
And there isn't really a good way to do that on manual machines. The best way is to have a turntable on the table of the Bridgeport, and you tip the Bridgeport head, and you do that kind of same geometry that we use for curve generating, only you're making, to get the curve right, you have to make these really minute adjustments, and you're using, there aren't a lot of cutters made for doing convex curves, like imagine a face mill, but with a big old gap in the middle. You have to build that, or you have to use a boring head, and that's not pretty either. So the VMC has been a huge game changer, because either I can ball mill that, or more often what I do when I need a good surface is I'll put the workpiece in the spindle, and I'll put a lathe tool in the chuck, and I'll run it as a lathe, because there's no rule in Machinery's handbook that says a dog can't play basketball.
And at this point, Prescott's internet finally gave up the ghost and just died, and he was not able to rejoin us again. So from here on out, it is just me and Harrison. So Harrison, you've had a lot going on.
Yes, I have. It's been craziness in my world since our last podcast. So when we last spoke about my new machine, it hadn't been delivered yet, correct?
With the podcast, definitely.
Yeah, because we did the shop tour, and I think I showed where it was going to go.
Yep.
And so I'll kind of start from that point. And so after that episode, the next day, the machine arrived, and Delivery honestly went super smooth. Um, so we had a fraction of the guys that showed up for the delivery of this machine, and it went twice as fast. So that was a lot of fun. Only 3 guys, and it arrived at around 8, and it was in the shop um, and ready for the technicians to start working on it before 10. So under 2 hours from off of truck to sitting on our floor uh, and ready to go. And so that part went smooth, and that was probably the only part that went smooth. Because after that, the technicians started working, and they found out that our power was the wrong voltage for the machine. And so I'm going to compare Haas and Doosan a lot because these are going to be the 2 machines I'm the most familiar with. But on the Haas machines, and talking to the on the Haas machines, there's different power taps that you can use depending on your voltage. I think it goes on my VF3. I think it goes down to like 205 volts all the way up to 260, and you have different taps depending on your voltage range um, through that stack. And so, whatever your input voltage is, you can adjust it to be able to compensate really easily. Talking to our Doosan.
To be fair, that might be a an add-on. That might be an option.
No, it's standard. We didn't add it in. So at least that's my understanding. Is pretty much all of them have it. And the reason I know it's standard is because my lathe did not come with as many taps, and they said that the lathes just have less taps, and so the range on my lathe is on the high side, but they had the right tap on the mill side, so it wasn't a big deal. But apparently Haas is one of the only machine manufacturers that really does that as like a standard. And when we measured our voltage, our electrician told us that we came in at 243, 242 volts. And that was right on the high end of what was acceptable for the Doosan. And when the tech showed up and he started hooking everything up, well, they dropped off the machine, and then we had to get it connected to power and air and a couple other things first before they would send out a tech. So machine gets dropped off. We hit the ground running with our electrician and getting the air plumbed to it and all that stuff. And then the tech comes 2 days later. So machine dropped off. We spend a day getting it ready, and then the tech shows up. Anyway, so a day or 2 later. And when the tech shows up, he starts putting everything together. And when he gets to turning on the machine, he double checks the voltages before he turns on the switch. And turns out our voltage was actually 247, not 242, 243. And I don't know if it was just because of that day, or um, if the voltage in the lines was going up and down or whatnot, but they basically said that they couldn't do anything until we fixed our power issue. And so we had to overnight a transformer, and that was a lot of work to get. So we got it. Well, before we overnighted the transformer, we talked to our electrician, who said that the power company might be able to change our tap on the service coming into our building. They said they couldn't do it. We lost a day to that, and so we overnighted a transformer. And then we got that hung up on the wall. And the transformer we were going to get was like 100 pounds. And then when we went to order it, we found out that it was a 6-week lead time. And so we had to order a larger one that was twice as expensive and twice as heavy. And we had to mount that up on the wall to make that work. And so, anyways, eventually we got power out to it. Eventually we got the tech out to it. He started getting everything put together, ran into some problems. And at that point, his support that he needed was a couple hours ahead of us. And so he couldn't talk to them. And we also found out that our conveyor was the wrong conveyor. And so apparently, whenever we ordered this thing, our salesman said that it could go out on the right or the left. And while that's true, you have to make sure you order it with the right version, and these are,
Or
or
the
the
left
left version. Yeah. Well, unfortunately, we got the right version and we needed the left, and so um, we went back and forth.
So right is wrong.
We went back and forth on that, and it was in the quote, and we signed the documents, and so it's our fault for not catching it. Um, which means we ended up making that work, but it means we had to come out and move the machine over 40 inches, the opposite direction. So we had to have the riggers come out again, and then we have to have the technicians reset up the machine. And so I mean, it's just been one thing after another. And like I said, on Friday, we finally got everything. Like it's been a week and a couple days when we finally started being able to cut chips on it after it had been delivered. And this whole week they came in on Monday and moved the machine. So when they got it working on Friday, it didn't have the conveyor in it, and the machine was in the wrong spot. And so they came in on Monday and moved the machine over 40 inches, and then we got the conveyor installed. We ran a couple parts over the weekend on it, so we got it set up enough to where we could try to get some production out of it on Sunday, but then we lost it production on Monday because we had to clean out all the chips, put in the conveyor, move the machine 40 inches, and get it all re-leveled. And anyways, it's running now, and we've had 2 full days of production yesterday and today. And
Nice.
I'm excited that it's actually up and running, and I'm starting to learn Fanic, and I have a new appreciation for how simple the Haas controller is compared to Fanic. Not to say that Fanic isn't like once you learn it, it's not too bad, but there's just a lot of little things that just annoy me about it. And some of those things I'm getting fixed with parameters. There's a lot of parameters that I'm changing around. So for example, one of the parameters that kind of annoyed me was whenever you're jogging the machine around, if you hit a limit, it'll throw an error and it'll alarm out the machine, and then it'll only allow the axis to go in one direction to get off that limit until you reset it. And so thankfully I talked to Dylan from Proteum Machining, and he said his brothers don't do that, and that there's a parameter that we can change, and the techs didn't know that I talked to, or at least one of them didn't. The other one did, or the other one knew that it was a parameter, but he wasn't sure if he could get to it on our controller, and we could, so we got that fixed. But then I found a new problem that is not a parameter, and I don't have a good solution for it. And that is, if I jog the hand wheel all the way forward and I'm in hand jog mode, and then I say I switch over to run a program in memory mode, that error comes back. And so I have to, if I jog it all the way forward manually, I still have to back it off in hand jog mode before I go and run a program. And so there's a lot of little things like that I found inside the Fanic controller that are just annoying. Whenever you do a tool change, there's no such thing as next tool, previous tool. You have to go and type it in an MDI and run a program to do a tool change. You say T33 M6 end of block insert run program type deal. So that's a little bit different. Not the end of the world. There's a couple other things, and then there's the scary part that if there's a little battery pack for the absolute encoders, and if that ever loses power, you could be hosed because it could lose where it's at, and then you have to redo the tool changer. And so that kind of scares me a little bit. But I mean, a lot of people use these machines, so it's only a problem if it happens. But if it happens, that sounds like a really bad day.
Yeah, it's just a regular maintenance task. Change the batteries.
Yeah, hopefully that's all it is. As long as the machine is powered on. If you take the batteries out, so once a year. Yeah. There was a couple other little odd things here and there. But I'm getting a lot more comfortable with it every day. And there's definitely things as I go back and forth. Right now, my biggest gripe with the machine is that, at least with the techs that I've talked to, none of them have used the tool life management on the mill side. And so even though they say that's a feature, they say only lathe guys use it, and so they only know how to do it on the lathe side. And so I'm trying to figure. I haven't messed with it at this point, but I would like to get it figured out, because that's one thing that the more I'm running production jobs on the Haas, the more I care about my tool life. And the Haas just has it built in where you type in a tool number, and it'll keep track of its cut time, how many times it's been called up, all that stuff. That's just on by default. The Fanuc does, or the Doosan doesn't have any of that on by default. And it sounds like you have to go into their tool management library and you have to go set up every single tool individually. Which, that was another thing that our Fanuc guys had never, or the Doosan guys techs that I talked to had never done, is we do things a little bit differently with our tool numbers. We use all the offsets in the controller and we just change out what's in the machine. So almost everyone uses like tool, if it's a 30 pocket, they use tool 1 through 30, or 31 if you have one in the spindle. The machine came with 400 offsets. So I was like, okay, so I can use T0 to T400 or T1 to T400. Why not? But there was something in the ladder logic that if you went up to past T69, giggity, that it would like go into this weird mode where it would only tool change between two different tools.
Interesting.
Yeah. And so like the tech had to spend like 2 or 3 hours digging around in the machine to figure out what was going on with the ladder logic, even though it had 400 offsets. And it turns out that there was a setting somewhere that was limiting it to 69 tools numbers, even though it had, on the tool offset page, it had 400. So, yeah.
It's one of those weird things when your machine controller isn't made by the same company that makes your machine.
Yeah.
Weird stuff like that happens. I want to take a step back to like the installation process. Yeah. Like, I know you say that it's not Doosan's fault that they sent you the wrong transformer or didn't send you a transformer, and that they sent you the wrong chip conveyor. They had a sales guy talking to you. You did not build this machine online. Mm-hmm. Like, if they want to insist that you go through a salesperson and not just price everything out online and choose what you want online, like, they need to actually take some responsibility. They can't, like, this is the salesperson's job to make sure that you get what you want. Mm-hmm. And it's his responsibility to make sure that, like, you get a transformer so that the machine can run, and that you get a chip conveyor that goes on the right side.
Yeah.
Like, you need to push back on them. They screwed up. And it costs you a lot of money. You need to push on them.
Yeah, but here.
What do you mean? So my local reps are Trimec. That's the name of their company. So they're not, I don't think they're actually actual Doosan employees. I think they're just kind of like Philips Corp is for us. Yeah.
So they work for Trimec. Well, the guy that made the guy who, well, and it might not have been properly communicated by us as well. Is it?
He should have asked.
So, yeah. Regardless of if who's in the wrong at this stage, it would have been another 6 weeks to get the right conveyor. and I'm not gonna go. It doesn't at this point. It's water under the bridge. If I was to do anything, I would have them cover the moving fees and the for
Yes.
that, and then that's our fault if our electricity is too high because we told them it was 240 because that's what we measured. But when they measured it with theirs, either we found out that we had a faulty meter, we got another meter and we compared it.
Hmm.
So that one is 100% on us. I'm not going to blame them because our voltages
Okay, I'll accept
are
that
out of
one.
spec, and so I'm not going to blame them for that one because we had a bad meter. But the conveyor one, it's clearly labeled on the paperwork we signed if you want to get technical, and um even if it wasn't and I wanted to really drag them through the mud on that issue, I'm not going to go 6 weeks with the conveyor without having a conveyor when I could just move it 40 inches and make it work. It's not an ideal scenario I want to be in, um but the machine ended up taking up much less space than the CAD uh made it look like it would. So it ended up being not as big of a deal.
I would still push on your salesperson a little bit because again, their business model that they chose is to have a technical salesperson walk you through picking what you wanted. That is his job. Haas, you're just like building stuff on the website and like, hey, I want to buy this. So in that scenario, if they don't catch something like this, it's fine. It is your fault.
Mm-hmm.
But they chose this as a upsell service. And like they need to take some responsibility. They can't have it both ways. They can't insist on a salesperson to add value to you, aka try to milk you for as much money as possible, but then also not take responsibility when their value add service screws up.
Yeah, and mm-hmm. I'll tell you what my litmus test was on how hard I pushed on this issue. And that was I went through all the documentation of the communications we had between the two of us to try to find if I specified a left-hand side at any point in the conversation. And I could not find anything other than maybe verbal between the two of us that said we want it as a left hand. If I could have found one shred of evidence on my side saying, hey, I asked for a left and that didn't get put in there, because initially we did ask for right because that was our original plan. But when we put it in the CAD, we switched it to left, and I have no documentation where we asked them to switch it to the left. And so, if I could find any shred of evidence, I would have done that. But at this point, it was an extra $500 to have them remove the machine, and so at the end of the day, it's not that bad. Mm-hmm. Oh, did we lose you?
Say, did we lose Prescott again? Well, at very least, you have good riggers. That's a good thing to know. Keep their number for next time. Prescott, you froze on us. I don't know if you can still hear us, but we can't hear you, and we have a not so flattering single frame of you.
And we were able to make that work because Trimec was working with them, and lost Prescott completely. Because Trimec was working with them, and we worked a deal with the riggers where they came out, and I think they only brought one guy, and then Trimec helped them move it with their one guy. So I think that's the reason we got such a good deal on moving it. And so Trimec did do what they could to help us move it over. And so at the end of the day, $500 is not the end of the world to be able to use the conveyor that they sent with us. And it's a learning experience for us, if anything else, to try to double check this stuff a lot closer going forward. So learn from my mistakes. Look over everything with a fine-tooth comb before you sign on any dotted line, because we missed that.
So how does it cut?
The face mills is where I noticed the biggest difference, and it is so much better than the Tormach or than the Haas in that respect.
The Haas.
I can really see it because I have to take really light passes with the Haas. Otherwise, the face mill will dive a little bit when it's cutting in. And you can tell whenever you go over any holes when you're using the face mill on the Haas, the whole thing will kind of shift as that cut's varying. And I see none of that in the Doosan. And so that dual contact is a big improvement for that kind of stuff. For everything else, I haven't noticed anything that like screams it's a lot more rigid than the Haas yet. But that one particular tool, you can definitely see a big difference.
So right now, someone says, "Hey, I will take your Haas and replace it with an equivalent Doosan." Do you do it?
It would have to have full 5-axis simultaneous trunnion capabilities.
Yeah, assuming same machine, different brand.
If someone did that, I probably would, but I'm not 100% sure yet.
Okay.
I've really liked my my Haas so far. Like it has not disappointed me in any capacity yet. Not saying that won't change in the future. As I put the Doosan through its paces more and more, my opinion might change over time. I reserve that right, hopefully.
Yeah.
But if speaking from today, I don't know. I don't know. I'll have to get more familiar with some of the features on the Doosan, and how I like Fanic. I will say, I've been thinking about my next machine already, and I think my next machine's going to be a Speedio. Yeah.
Oh, really?
Yeah, I think that's what we're leaning towards. So
I think this is a good choice.
So I'm really wanting to look at that U500 for my next machine. A little bit of background on that. My workload here recently has been increasing like crazy, and one of the new customers that I've started taking on work for, right now they're they're whispering sweet nothings of potential deals that could happen, and when it happens, I'll believe it. But there's a potential for over 20,000 parts a year of different SKUs, and that would be enough work to keep one machine busy indefinitely year round for sure, and potentially more. And that's where I'm really looking forward to IMTS, because I could see automation coming into the equation, and so I would either get a dedicated 5-axis, or I'd get automation on my Haas and automate the 5-axis on there to be able to change it in and out. So we'll see. Lot of potential, and that's why I've been busting my butt here recently, is because they've absolutely buried us in work for the next month or two. So, which is why over the last 2 days, yesterday and today, I think yesterday we did the most amount of parts we've ever done in a single day, and I think we did over 150 parts. And that was between the lathe, the Haas, and the Doosan. So the 2 mills and the lathe. And ironically, it's in the reverse order of the quantities you would think. The lathe produced, or the 5-axis produced the most parts, The 3-axis produced the second most parts, and the lathe produced the least. So it's like in the reverse order of what one might think.
Yeah.
So,
yeah, you already need another machine, which is wild.
so we'll see. I've definitely putting in crazy hours, but now that the Doosan is running, I'm starting to get a handle on my the parts that we're running, and I'm finally starting to kind of get caught up on some things. And we were up a really big creek with the due dates on a lot of these projects, and I ended up having to call a lot of my customers and talk to them about, hey, I'm not going to be able to hit this due date. Is there anything we can do? Like how urgent is this? You know, what can we do to make this right? And out of those conversations, um, they pretty much all gave me extensions and said that they were overjoyed with our work and offered to send more work our way.
And you're like, well, yes, but no, I'm so far behind.
So,
stop it, he's already dead.
So, they basically asked, what machines is sitting, and I said my lathe is sitting, and they're like, oh, we got a lot of lathe parts we could send your way. I'm like, thanks. So I might be getting a lot of lathe parts from one of these guys. Actually, from two of them. Two of the customers asked me which machine's sitting the most, and I said it was the lathe. And so that might get busy, which would be nice. And they're kind of opposite ends of each other.
Yeah.
Because one of the customers wants parts that are realistically Swiss lathe parts. Like they're the perfect Swiss lathe part where they're under they're about a ½ inch in diameter and about an inch long. And they'd be awesome on the Swiss. And then the other customer is wanting massive slugs of like 8 inches in diameter. That would be chuck work with our big on the lathe instead of collet systems. So I'll have to see what's going to happen there. So yeah, that's kind of what's been going on in my world. Oh, and we do have a thing that we just implemented this week because of all this craziness. We have informed some of our customers that we are no longer doing gun parts. Barrel threading, RMRs, anything related to firearms on a small scale one-on-one basis is done. And so it's hard to do that just because I like that connection to the community and whatnot. But at this stage in the business, we're starting to niche, like get into our niche, and we need to start cutting the fat in some different areas of the business and focus on what's making us the most money. And I can say for certain that I am loving high volume runs, which it seems like most people in our space are kind of that high mix, low volume bunch. And I'm kind of going towards the higher volume side.
I think a lot of successful machine shops are more what you're doing. They just don't get talked about as much, and it's like a little less sexy. But I mean, I think your way is the smart way. I think the high mix, low volume is kind of the I don't want to say less intelligent way of doing it, but
it's more engaging.
I don't know, less ideal.
So like,
yeah, it's also, I don't know, more risky. Maybe risk differently.
I can say between the last 2 weeks that I've been working like a madman, everything's been the same part over and over again. And so it's been coming up, pushing buttons and keeping the machine fed more than anything else. And the cycle time on the Haas is about 30 minutes, and the cycle time on the Doosan is about 5 minutes, which really sucks. Which it's funny because the cycle time on the Doosan is significantly less than the Haas, but it's stopping so frequently that I can't keep it fed. And so even though the cycle time's longer on the Haas, I'm getting 4 parts per button push versus 1 part per button push. And so I'm producing more parts on the Haas because it's easier to keep it fed than the Doosan.
Yeah.
So, which is really for this higher mix stuff, I've got to palletize more and more, because that higher cycle time of loading up a machine and just letting it run, um, even though my cycle times, like I said, is longer on the Haas, I'm producing more parts in the same amount of time. So it really makes a difference.
Yep. I don't know. Sometimes higher volume production work. Sometimes higher volume production work sounds very nice. Like, you know, making this part was nuts, and it took me an entire day. I'm really happy with the results, but when I was making this part, it was a lot of, man, I wish I could just be pressing go on my machine and getting completed parts. And
in an ideal world, I want both. I want the ability to have high volume parts as my cost per part on almost everything that I'm doing is like under $20 a part. And so like the part cost is really low. But it's also, once you get the program set up and running, it's just going in the background. I don't have to worry about it. I have to check to make sure the parts are coming off good, no tools are broken, but other than that, it's just monitoring and making sure everything's flowing smooth. And so having a machine like that going in the background, especially with some form of automation where it's automatically loading and unloading, that job in the background will cover the baseline of the business, where I don't have to worry about do I have enough work, or do I have do I have enough jobs coming in. That's going to be my foundation for the company. And then I can start doing the more onesie twosie stuff and still have a nice variety, but have my baseline covered. Is kind of where I'm leaning towards. It's kind of what I'm trying to do.
I mean, if I were you, I wouldn't worry about onesie twosie stuff at all. Like, just focus on the high volume stuff.
Yes, except for I will go crazy if I only do high volume stuff.
Find a hobby.
This is my hobby. This is my hobby. I learn
find a new hobby.
So much more from the onesie twosie stuff than I do the high volume. Like I learned different things. So
that's fair.
So like they both make me a better machinist, but in different areas. You know, just like we talked about how the Xometry jobs, taking on jobs that are right outside your scope. The high mix, low volume gives me opportunities to try things and experiment and test out tooling, and then the higher volume stuff gives me the ability to optimize. And that's the thing that I've really enjoyed doing about the high volume work, is optimizing the program and chasing, we're doing a run of 2000. And so for every minute saved on 2000 is 2000 minutes. When you divide that all the way down into hours, it's like 33 hours. And so 1 minute saved per part saves you about a week of machining. And I have a lot of fun like going in there and being like, okay, what's this little one tweak do? What's this other little tweak do? Which, speaking of which, the Doosan accelerates like 10 times faster than the Haas. So they might have the same rapids, but the Doosan, it's just like there. It's like instantly at speed, versus the Haas. It can rapid just as fast, but it takes a lot longer for it to get up to speed. So I definitely,
which can make a big difference on cycle time.
That's the biggest problem I'm facing, is like, according to the computer, my cycle time on the Haas, that's like 33 to 35 minutes right now, somewhere in that range. It should be under 20 minutes by computer simulation time. And that's with me overriding and slowing things down to what a normal, what is normally accurate for one part at a time on the Haas. But because of all the linking moves, because I have 4 parts on this and I got patterns in there, and it's not calculating all those linking moves, it's added a ton of cycle time. And what's really wild is I can, quote unquote, add cycle time in my program, but it results in less linking moves and actually speeds up my parts. So that's like a little backwards, and it's just because of the kinematics of the machine. I can force it to do some things that look like they're less efficient on the computer, but they result in um, more thought out motion on the machine, which speeds it up.
Yeah.
So, but I'm hitting a wall. I haven't been able to get it under 30 minutes, and I think it's just because that rotary on the Haas is really slow compared to the rest of the machine, and repositioning on the 5-axis, it's like watching paint dry. It's so slow compared to everything.
And so this is why you're looking at a Speedio.
Like, I bet with a Speedio these parts would be like 15 minutes for 4, and that kind of speed up is just insane. So I kind of want to, if possible, I would love to load these parts, like talk to a Speedio rep and test run. If they have like a laying plate that I can set my thing on and then load up the tools and like run them or something, or like do a time study, I would love to see what kind of speed up could be possible. That and RPM.
Yeah, well,
is
Yamazin your Speedio dealer?
Yes, and
I assume they would be.
I think I have a Yamazin tech coming tomorrow or Friday. So
yeah, they should let you run a part.
Whenever I got a quote from them a little while back, the guy called me up and said, "Hey, I'm going to be in your area," and so I think he's going to come either tomorrow or Friday. So
nice.
I'll get to talk to him a little bit before IMTS, and he's going to be at IMTS, and I'll be able to actually go look at some of those machines while I'm there. But yeah, there's stuff changing like crazy. We got our sign up on the front of our building since our last podcast, and we got the little awning finished up as well. So there was so much that I was going to talk about on this podcast, and I'm starting to draw a blank because I know there's a lot more.
Sorry.
You said you had a lot of stuff to talk about as well. Is there anything else? Because I've been talking for a while. Is there anything else you want to add from your side?
I don't know. It's starting to get late here. Maybe we should put on some of it on the next podcast. This is the second time where I have taken a project that was all, or at least consisted of some video stuff. And like at first on paper, it seemed like it was a really good deal and I would be making a lot of money. And then it's taken me a lot longer than I've expected. So I might need to reconsider something there. The rates that I'm charging, like compared to industry averages, are maybe not way above, but they're above. Like I'm not giving them low numbers here when I am quoting them. I think it's more it's more just that it's so different from other stuff that I've done that I'm not very good at it. And so it's taken me a lot longer. Because like this project that I'm working on now, I had originally thought would be like 3 or 4 days, which would have been like banger better than any Xometry job I've taken in terms of like profit margin and like pay per days or whatever. It would have been fantastic. But now I'm at a week and I still don't have a finished project and I still haven't edited the video. So I think part of it is I just really suck at multitasking. Like, if I have a part that's like 45 minutes on the machine, I have a very hard time like going in and like switching to some other project and doing CAD on that. Like I don't know. I just have a hard time with that. And I think that is probably half of my problem.
Makes sense.
Fortunately, I did get a repeat Xometry job. And it's one that went very well for me last time. And now it's 20 pieces. I think last time I did 1 piece or 2 pieces. And now I'm doing 20. So it should be, there's no custom fixturing. There's nothing weird. There's some small tools, but that'll give me some time give me something that I can just run while I'm editing this video.
That's good. How long was the cycle time for those parts that you did for IMTS? Was it pretty long or was it pretty quick?
Yeah, a lot of them were pretty long. The gears weren't so bad. There's 3 gears, 2 of which I have done right now. Those were about an hour each total. This thingy here, which has a bunch of surfacing, that thing took a long time. That was like 4 hours. These rings, which have both like some fancy surfacing on one side, and then they have a internal gear. Those were probably 3 hours each. Lots of small tools, lots of surfacing, and all in titanium. Probably should have made this project out of aluminum. It would have looked the same in the end. But
at the very least, if you did it in aluminum and you wanted to do that titanium, you could have had it all proven out and then changed out parts.
Yep. My problem is I wanted to anodize it, and I'm not set up to anodize aluminum. I can anodize titanium. Mm-hmm. That's why I went titanium.
Yeah, but couldn't you have made the parts in like a fraction of the time in aluminum?
Yeah, I could.
So like, if you're having to remake titanium parts, making aluminum proofs probably still could have been worth it.
Yep, I should have made an aluminum prototype first. That probably would have saved me time in the long run.
Yeah.
And I could have just sent that because I am so far behind. I got started on this project I didn't even mention the Xometry. I had a Xometry project go long. It ended up shipping like a day late, but it was like 6 days after I had intended to ship it. And that means that I got started on this project about a week late, and then it's also taken me, a few days longer than I expected it. So these are late at this point. Fortunately, it is an IMTS demo part, and like IMTS isn't here yet. Worst case scenario, I stick it in my suitcase and I go put it in the Autodesk booth myself.
Yeah, we're less than 2 weeks away.
Yeah. Oh, by the way, IMTS meetup 2 p.m. Tormach booth Monday, the 9th of September. Bring a part if you guys make parts that you can carry.
Yeah, 2 weeks from today, we'll be ending our IMTS event that we're there for, because we'll be heading out on end of Wednesday or Thursday morning for us.
You need to give me details on when I need to pick you up from the airport.
I can get you that. So, yeah. Oh, I'm so looking forward to IMTS, but I have so much stuff to get done before then. Parts.
I'm looking forward to IMTS, but I'm also dreading it. Like, just because everything I have, like, it feels like everything I have to do, the deadline is IMTS.
This 2,000 piece order I'm doing, I have to produce 280 parts a week for this order, and that includes the week that I'm at IMTS and gone for 3 days. So I have to get ahead, and I haven't been able to get ahead yet, mainly because
Won't you be gone for 4 days?
We'll be back Thursday morning, so I'll have I'll be gone. So we're getting there Monday morning, and then we're leaving out Thursday morning. So we'll be back at the shop by Thursday afternoon.
I have no illusions that I will be useful in the shop that day. There is no way I'm going to get stuff done on Thursday, or probably even that Friday. I will be so dead.
I have a customer coming by on Thursday, so I have to be back in to meet them. So Thursday afternoon.
You're a people person, so you'll survive IMTS better than I will.
I'll survive it, but at the rate I've been going, I think I did the math. I was doing 90. I did over 90 hours the last 2 weeks, I think, a week.
Each week.
So, like, when I went to class,
start your own business. They said. Get freedom to work whenever you want. They said.
When I went to class this week, yesterday, for the first time to teach, I was like so out of it in front of these students. I've been in work mode for so long and so hard the last 2 weeks that like I got there and just started rambling. I don't even know what I said the whole time. So
that was the first class though, right? Yeah. Just syllabuses and stuff.
I had a teacher that is what do you call it? not taking the class but observing it. And so they were sitting in there the whole time while I'm just like out of it. So it's like I'm not drunk. I'm just dead. Oh.
All right. Well, speaking of not being drunk,
All right, guys. It's that time where we say goodbye. And thank you guys for listening to this podcast. And even though we're both absolutely worn out, we still managed to go really long. So, yay us. So, thanks guys for hanging out with us. Prescott, thanks for hanging out with us. Even though you're not here anymore, I'll do a shout out to you. Thanks for.
I did get a message from him. It says, "I'm sorry, the internet cut out and then my family exploded." Which, as a parent, I understand.
Yeah, so glad to have him on for a little bit, and had a lot of fun with the other people from the Patreon. So we need to do that again. So yeah, this has been Harrison with Precision Ingenuity, signing out with AJ from Audacity Micro. We'll see you guys next time.
Don't forget the IMTS meetup.